Hey guys, welcome to Simplifying Radicals, Search for the Perfect Square. So this is kind of a second part to the video Simplifying Radicals, where I showed with the prime factorization method. All right, so just as a recap, we are talking about radicals. We are going to be focusing on actually square roots, so simplifying square roots, not necessarily radicals. So just a reminder, radical symbol, index, our index is going to be a 2. Which means that it's really just not written. Anything underneath is going to be called the radicand. The whole thing is called a radical. FYI, you're probably going to hear the bell go off in this video, so apologize for that. All right, so in the first video, we talked about the prime factorization method, and I started with the example of the square root of 32. All right, so with the factorization, you break it down, you'd make a factor tree, and you collect all of the primes. Okay, but instead, we need to start thinking in perfect square mode. So we want to start thinking, well, what are our perfect squares? We have our smallest one is 4 because that's 2 squared. Then we have 9, right? And then after that, sorry, I'm having brain fart here, 16, then 25, 36, 49, 64, 81, 100. Okay, I would say the best ones to kind of always ask yourself and really just know, does 4 go into it? Does 9? 25 is a nice, easy one to recognize. And what about 100? All right, those are like the main ones. Okay, if you're not sure where to start, you can always fall back on that prime factorization method. Okay, so if I'm looking here at 32, I could ask myself, I could take a look at my whole list and be like, you know what? Thinking about my perfect squares, what's the biggest perfect square that would go into this? Okay, so if I thought about it, I'm like, well, 4 does go into it. Is there a bigger one? Does 9? No. 16? Why, yes, it does. So if we were to start off, I could have gone, hey, this breaks up into the square root of 2 times the square root of 16. All right, so if I happen to choose those two factors, that makes my life so much easier. Okay, well, this is already simplified. Nope, there's the bell I was telling you about. Okay. So that's already simplified, nothing I can do there. But instead of keep going with factoring this, don't I know what the square root of 16 is? It's 4. So I can just stop right there. Now, I don't leave my answer like this, okay? Our perfect squares always go first. Perfect people, we always put them ahead. Not saying I agree with that, but all right, so we get 4 radical 2. Okay? But you're like, well, Miss Paris, so what if I didn't see 16? What if I just said, you know what? I think of it as 4 and 8. Well, there's no problem with that. So if I were to rewrite this as the product of square root of 4 times the square root of 8, that's fine. Okay, well, what is the square root of 4? The square root of 4 is 2. Now, you might be like thinking, well, 2 times the square root of 8, we got 4 radical 2. That's 2 different answers. Okay, well, that means that we're not quite done. If this is not a perfect square and this is not a prime number, you want to break it down and make sure that this other radical is actually simplified all the way, and there's no sneaky little perfect squares trying to hide out in there. So I would go ahead and break this one down to the square root of 4 times the square root of 2. Again, when in doubt, always check that 4. 4 is your smallest perfect square that would go into a number, so that's always a good place to check. And square root of 8 breaks into 4 and 2. So there was another little perfect square hanging out in there. So that would become a 2. So now we do our smooshing. 2 times 2 is 4, and we have radical 2. Okay? So in this method, instead of going and making a big factor tree, we are able to we are on the search and on the hunt for the perfect square. Okay? So kind of like playing some hide and seek there. All right, let's try the other example from the last video, which was the square root of 270. Okay, so again, this is where if, like last time I did was I factored it into 27 and 10 to try to find all my primes. Okay, so my first thought is it a perfect square? No. Okay, Next question I'm going to ask myself, can I divide it? Let me check my main ones. Is it divisible by 4? Maybe, maybe not. 9, oh yeah, 9 goes into 27. So you know what? I'm going to start there. So I'm going to break it up. 9, well, 9 times 3 is 27. So 9 times 30 is 270. Okay, so if I well, I don't need to break this up. I know that the square root of 9 is 3. Now, I need to check. This is not a prime number, and I'm not really sure if any other perfect squares are hiding in there. So I can think to myself, does 4 go into it? No. Does 9? No. 16? Nope. 25? No. Okay, well, I can stop. It's not going to be any number bigger than that. So I could just say, hey, this cannot be divided by any more perfect squares. But if I wasn't sure, I would just take it and break it apart. Be like, you know what? I'm going to break this apart to 3 and 10. I'm like, okay, well, that's prime. Let me keep going here with this one. Square root of 2. So we're falling back on that prime factorization method. And be like, okay, well, look, I didn't have any twins, so these would end up just getting smooshed back together. So like, okay, well, that's just going to be 3 times, well, 3 times 2 times 5. That just takes me back to the original problem, which was 3 radical 30. Okay? So with this hunt for the perfect square, you're kind of merging the prime factorization twin method and the hunt. Okay, so 30 couldn't be simplified any further. So our final answer is 3 radical 30 or 3 root 30. Okay, let's try one more together. Let's say I had the square root of 800. Again, take a look at your main ones. Now, I don't know about you, but the first thing that I see is I see the double zeros, so I know that I can divide by 100. So that is my first thought. It might not be the largest perfect square that goes into it, but it's definitely the one that stands out the most to me. Okay. All right. So I don't want you to think about this anymore like as a factor tree as so much as now we're starting to rewrite it as a product. Okay. So I can now simplify that and I get 10. It's no longer under the radical because I applied the square root. Here, this is not a perfect square, but I'm going to break it up and check. I know that that perfect square of 4 is actually hiding out in there. So I'm going to rewrite the square root of 8 as 4 times 2. And well, no, that's actually 2. So 2 times 10, remember, you only multiply the ones that are, the numbers that are outside of the radical together, and anything that's under the radical you would multiply together. So smooshing outside or smooshing inside, no mixed smooshing. Okay, so we end up getting 20 radical 2. Okay, and again, now maybe, all right, so again, look at that. We had 20 radical 2. Maybe you saw it as 2 times the square root of 400. Maybe you know that 400 was your perfect square, and that would have made your life. So the larger the perfect square you know, the quicker you can work through the problem. So the square root of 400 is 20, and there's no other radical, so 20 radical 2. Okay? So always try to look for a perfect square. Try, like, again, your go-to ones are really 4, 9, 25, 100s. Those tend to stand out to us the most as we're doing those. Alrighty? So good luck with your hunts for the perfect square. If not, watch out for those evil twins. And let me know if you have any questions.